Welcome back to Clelland Maths. Today we are doing a full topic masterclass on higher maths straight line. This covers everything in the course spec from basic gradients, parallel and perpendicular lines to your medians, altitudes, points of intersection, gradient equals tan theta, everything you need to know. Now, I've put together a free revision checklist and a formula sheet. You can get that in the link in the description or in the pinned comment. And let's get started with example 1. Find the equation of a straight line through 4 minus 1, but it's parallel to the line with equation 2x plus y equals 5. So remember, these are taken from the excellent site maths.scot, and you can also go on the app.clellandmaths.com to do these questions yourself as you go, okay? So we've got parallel means same gradient. So we've got y equals, I'm just rearranging that one, minus 2x plus 5. So the gradient equals minus 2. And it's the same since parallel. And now all we need to do is y minus b, mx minus a as normal, y minus 1, minus 2x minus 4. So finally y plus 1, minus 2x, minus 2 times minus 4 is plus 8, or y equals minus 2x, 8 minus 1 is 7. And we're done there. Example 2. A and B are points minus 8, 7 and 2t. The line AB is parallel to the line with equation 5y minus x equals 9. Find the value of t. So we're still on parallel gradients, so we can rearrange to find the gradient. 5y is x plus 9, so y is a fifth x plus 9 over 5. The 9 over 5 doesn't matter, but we know our gradient equals a fifth, which is since for parallel. Now, gradient formula from National 5 Maths, y2 minus y1 over x2 minus x1. So we've got our gradient equals, well, if we call that x1, y1, x2, y2, t minus 7 on the top over 2 minus 8. We know that equals 1/5, so we've got an equation to solve. T minus 7 over 10, because 2 minus 8, equals 1/5. So now we can just do that times that equals that times that. 5t minus 7, a bit of cross multiplication there, equals 10. So t minus 7, well, we'll actually expand it because that's what most people would do. 5t minus 35 equals 10. So 5t is 10 plus 35 is 45. So t must be 45 divided by 5, which is 9. And we're done there. Okay, example 3. The line L1 has equation 3x minus 4y equals 1. L2 is perpendicular. So we're going to use perpendicular gradients here. M1 times M2 equals minus 1. So let's start off, and the two lines intersect at 3, 2. Find the equation. So we've got a point. Remember, for a straight line, we always need a point and a gradient. So rearranging, we've got minus 4y equals minus 3x plus 1. So I need to divide by minus 4, minus 3 over minus 4x, and then plus 1 over minus 4. But we'll never leave it like that. That's awful. A minus divided by minus is a plus. 3/4 x, and then minus 1/4. You wouldn't leave a minus in the bottom either, so watch out for that. So the gradient of this one is 3/4, which means our gradient of our perpendicular, I just usually draw a right angle there, is equal to the negative reciprocal. Well, what does that mean? It means you flip it upside down and change the sign, okay? So we've got minus 4/3 because M1, M2 equals minus 1. Now remember, if you want extra help on straight line, I do have full topic teaching available in the full course playlist, but this is a masterclass as we're running up to the exams. Now, the grade points intersect at 3, 2, that's A and B. So we've got y minus 2 equals minus 4/3 x minus 3. So to deal with that, it's a fraction. I'll take the 3 up to the other side and leave the minus 4 where it is. 3y minus 2, well that's minus 6 of course because I'm multiplying the brackets out, is minus 4x. A minus times a minus is a plus. And I've missed my x. Now, we don't need to change it back to y equals. It's acceptable to leave it as yx and then number on the right, or yx number and 0 on the right. So that's what I'm going to do. 3y plus 4x, moving the x over. 12 plus 6 is 18, and I think that would be acceptable, but you could write 3y plus 4x minus 18 equals 0 if you prefer, or even switching x and y's on, who really cares? Let's move on to the next one. Okay, here we are, example 4, collinearity. So 3 points A, B, and C are defined as them. Are they collinear? Now watch out for this one. You need to make sure your way you say this is on point. So we need to check if the gradients are the same first of all, and then we'll do our statement. So are they collinear? Well, let's check the gradient of A to B. So that could be 7 minus 5 over 10 minus 1. Well, 7 minus 5 is 12. 10 minus 1 is 9. Always simplify. Divide by 3 to get 4 thirds. So our gradient of BC, minus 1 minus 7 over 4 minus 10, minus 8 over minus 6, which simplifies to 4 thirds as well. So what can we say then? Well, this is where we need to be careful. Since we can just say the gradient of AB equals the gradient of BC, what we actually know is that the two bits are parallel, and that's what we need to say. So that means that AB and BC are parallel, and then you need to write a further statement to say that you've got a common point, and therefore they're collinear. So watch out. B is a common point, and then you write your statement, therefore, 3 dots for therefore, A, B, and C are collinear. And we're done there. Another example on collinearity. Example 5. 3 points P, Q, and R defined as minus 1, 2, 2, 8, and minus 4, 7. Are P, Q, and R collinear? Justify your answer. Same idea. Find the gradient of each segment. Doesn't matter what you do, by the way. You could do P, Q, Q, R. You could do P, R, Q, R, as long as you use one with the same point. But we'll do P, Q. So 8 minus 2 over 2 minus 1. 8 minus 2 is 6. 2 minus 1 is 3. And that gives me 2. The gradient of QR is minus 7 minus 8. Minus 4 minus 2. Well, that's minus 15 over minus 6, which I can simplify by dividing by 3 to minus 5 over minus 2. Well, actually, 2 minuses make a plus, so I get 5 halves. So then we can make a statement. Since the gradient of PQ does not equal, an equal sign with a line through it, the gradient of QR, then PQ is not parallel to QR. So P, Q, and R are not collinear. And we're done there. Example 6. The line L1 makes an angle of 30 degrees with the positive direction of the x-axis. Find the equation of the line L2, which is perpendicular to L1, passing through the point minus 3 to root 3. So, perpendicular gradient means M1 times M2 equals minus 1. That's the main thing. But we've also got angle. Gradient equals tan theta. So for L1, gradient equals tan 30. This is an exact value because non-calculator. I remember my triangles. Here's how I do it. Little trick. 1, 2, 3. Simple as that. And just remember to root the third one. And then that is 60, 30. I just remember 60, 30. I used to have other ways to do this, but just remember it's 60, 30. So how do we get 30 then? 1 over root 3. So that is the gradient of L1. Find the equation of L2, which is perpendicular to L1. So L2, the gradient must equal straight away minus root 3, since m1 times m2 equals minus 1. Don't forget the statement. Now we move on and use our point in the usual way, y minus b equals mx minus a. So we've got y minus 2 root 3, funky numbers, equals minus root 3 x minus minus 3. Y minus 2 root 3 equals minus root 3 x plus 3. And finally, so y minus 2 root 3 equals minus root 3x minus 3 root 3. So y is finally minus root 3x. Minus 3 plus 2 is minus 1, so minus a root 3. And we're done there. Example 7. The line L1 has a negative gradient and makes an angle of 30 degrees with the negative direction of the x-axis. I think we're getting tricked here. Find the equation of the line L2, which is perpendicular to L1, passing through the point minus 3, 2 root 3. It says the negative direction of the x-axis. Gradient equals tan theta, for theta being in the positive direction of the x-axis. So if I draw you a little picture to illustrate that, if I've got this line, say L1 here, it's saying that this is 30 degrees, but I need the other side. So the other side is 150. So just watch out for that. So that means my gradient is equal to tan of 150. Now, how do I find the tan of 150? Well, really, actually, if it's a non-calculator paper and I find the tan of 30, if I use a cast diagram, how weird, I know. So let's just have a look at that. At the side, the tan of 30 from a triangle like this is 60, 30, 1, 2, 3, put a root. So 1 over root 3. But using a cast diagram now, or just by seeing, right? 150 is here, where tan is negative, because it's S. So that means that the tan of 150 is minus 1 over root 3. So we get that. Now we can move on to our next stage, which is to say that the gradient of L2 is equal to root 3, because m1 times m2 equals minus 1. You always need that statement. And we've already got our point, so y minus b equals our m x minus a minus minus 3. Y minus 2 root 3 then equals root 3 x plus 3. Y minus 2 root 3 equals root 3x plus 3 root 3. Almost there. Y equals root 3x. 3 plus 2 is 5. So 5 root 3. And we're done there. Example 8. Determine the acute angle of the line with equation 2x minus 3y equals 1 makes with the y-axis, not the x-axis. So gradient equals tan theta for finding an angle. So we'll go through there and we'll rearrange the equation. Minus 2x add 1. Y equals minus 2 over minus 3x plus 1 over minus 3, which looks very nasty. Minus divided by minus is a plus. So we could say that the gradient is equal to 2/3. It's a calculator question, so we can use it for our angle. Gradient equals tan theta. So that equals 2/3. So our theta would be the inverse tan of 2/3. And we'll do it as an angle. Shift tan 2/3 is 33.7 degrees. But remember, that's with the x-axis. So if you think of it this as a picture, it's something like that. Now, if we imagine shifting that line over to here, or shifting the y-axis to there, you would have this situation. So the angle it makes with the y-axis is going to be here, which adds up to 90. So our actual angle for our answer is 90 minus 33.7, Now I'm not going to try and work that out at this time of night. You probably wonder what time of night is that. About 8:05 on a Thursday evening. 56.3 degrees. And we're done there. Example 9, PQR are points 2 minus 1, 6, 7, and 3 minus 2. No jokes, we're in 2026 now. In a triangle PQR, determine the equation of a median through R. So, median means midpoint. So, I like to draw this if I'm not going to diagram, just to give me something to work with. So I'll just draw a random triangle, let's say PQR. Let's just call it PQR. It does not have to be exact, or coordinates don't have to be where they're meant to be. It's just to get a picture. It says median through R. There's R. Median through it means the line that cuts this in half. And that shows me what I need to know. I need to know the midpoint of PQ. Because if I know the midpoint, then I can use the gradient between them and then y minus b is mx minus a. So mid of PQ, remember to find the midpoint, you add the coordinates in half them. So 2 plus 6 divided by 2 minus 1 plus 7 divided by 2. 2 plus 6 is 8, divided by 2 is 4, 7 minus 1 is 6, divided by 2 is 3. So there's our midpoint, so we'll just call that M. And then we can say we'll find the gradient of M in R, because we always need a gradient, and we can't find it any other way. So R, remember PQR is 3 minus 2, I'll just note it there. So we've got y2 minus y1, 3 minus minus 2, over x2 minus x1, 4 minus 3, that's 5, over 1, which is 5. That's not changing, that is the gradient. Now we just use a point. You can use 4, 3, or you can use 3 minus 2. I'll just use 4, 3, because why not? So y, x, and a and b, sorry. Y minus b equals mx minus a. Y minus 3 then is 5x minus 20. Finally, y is 5x. Minus 20 add 3 is minus 17. And we're done there. Example 10, a and b are both coordinates. Determine the equation of the perpendicular bisector of AB. So in higher maths, perpendicular bisector can be used within a triangle, or in this case, just a straight line. It means perpendicular, cut it at right angles, bisector in half. So it's just an altitude, essentially, and a median. So if I imagine I've got a line like that, I'm looking at a line that goes like this, cuts it in half at right angles. So there's my A and there's my B, say. I want the gradient of A and B to work out my gradient. So minus 6 minus 4, 7 minus minus 3, that's minus 10 over 10, which is minus 1. That means I immediately know the gradient of the perpendicular is 1, because m1, m2 equals minus 1. Now I find my midpoint. Let's call my midpoint m. Remember, to get your midpoint, you just add the coordinates in half them. So I've got minus 3 add 7 divided by 2, and I've got 4 plus minus 6, 4 minus 6 divided by 2. So that's going to give me 7 minus 3 is 4, so that's 2. 4 minus 6 is minus 2. Minus 2 divided by 2 is minus 1. And now it's just y minus b is mx minus a again. Y minus minus 1 equals mx minus a. So I'm using the point 2 minus 1 because that's the only one on the line at right angles. Y plus 1 equals x minus 2, x minus 3 when I move that 1 over, and I'm done there. Example 11. In triangle KLM, the vertices KL and M are points minus 4, 1, 1, 7, and 3, 3. Find the equation of the altitude from K. So let me draw a picture for that. So K, L, M, and altitude cuts the opposite line at right angles, not necessarily in half. So we need to find the gradient for part A of LM. So L is the middle one, 1, 7, and M is the 3, 3. So our gradient is 3 minus 7 over 3 minus 1 minus 4 over 2, which is minus 2. We can say that the gradient of our perpendicular is equal to a half, since m1 times m2 equals minus 1. And we have to find the equation of altitude through k. We want to know the point k. So the point k was 4 minus 4 and 1. That's our k. And we've got our gradient is equal to a half. So y minus b equals m x minus a minus 4. 2y minus 1 equals 1x plus 4. 2y minus 2 equals x plus 4. I'll just write 2y minus x equals 4 plus 2 is 6. And that's fine for part A. Part B says determine the coordinates of the point where the altitude intersects a straight line through L and M. So it wants us to find a straight line through L and M, so I'm going to have to find the equation of that. So for part B, we already know the gradient of L and M, I think. I think we did that in part A. That was minus 2. So then we'll just pick a point. We could pick 1, 7 or 3, 3. Well, 3, 3 seems more reasonable. So y minus b equals mx minus a. Y minus 3 minus 2x plus 6. So y equals minus 2x. 6 plus 3 is 9. Now notice I've ended up with two equations not in the same form. So to work these out simultaneously, there's a few ways you can go. You could substitute that in for y here. That's a way to do it. Or you can make them both look yx number, and do the National 5 Maths version. I'll do it that way. I think that's the most common way most people do it. So for that, I've got 2y minus x equals 6. I'll keep that y there. Minus 2x becomes plus 2x, and that equals 9. Simultaneous equations. I'll double the top one. 4y minus 2x equals 12. Y plus 2x equals 9. Signs are different, so you add. 5y equals 12 plus 9, which is 21. So y is 21 over 5. Horrible answer, but there we are. Just if you've done everything right, it is correct. Now we move on to our x, so we'll just sub into one of our equations. Let's just pick this one. So we've got from star 21 over 5 plus 2x equals 9. So 2x is 9 minus 21 over 5. So 2x, 9 5s is 45 minus 21 over 5. 2x, 21, 31, 41 is 24 over 5. And then dividing by 2, x is 24 over 10, which is 12 over 5. So our point is 12 over 5 and 21 over 5. And would you say this is non-calculator? It was. So exact values, kind of a reminder there, the exact values of what the S we are really looking for in the paper 1 especially. So that's about as close to the exam as it gets. We're going to go through some exam questions now. Obviously, I'm not going to go through every single exam question that's come up. I've done that in other videos. You can see that in the links. But I've also put together a homework sheet to go along with this, and I'm going to film that as well. And that's going to be in for the channel members. So if you want some really extra practice on this that really supplements this, join the channel now to get access to the homework vault, and we'll be doing this for every topic at Higher Maths, where you get an extra sheet that you can work through independently, and then I'll give you the full video solutions to that as well, and you can really see if you've mastered it or not, especially at exam level. Let's move on to example 12. SQA Higher Maths 2017, paper 1, question 7. These are vertices of a triangle. Find the equation of a median through C. So we want to do a triangle of ABC, and the median through C means the midpoint of A and B is what I need. So if I call that M is equal to minus 3 plus 7 divided by 2 and 5 plus 9 divided by 2. 7 minus 3 is 4, divided by 2 is 2. 9 plus 5 is 14, divided by 2 is 7. So we get 2, 7. So we need the gradient between m and c. Well, that is 7 minus 11 and 2 minus 2. We're getting there. So 7 minus 11 is minus 4 over 0. Can't divide by 0. Now, if you can't divide by 0, that means, therefore, it is a vertical line. Now, you could have seen that before this point, but I don't think many would. That's just why I went to the problem of doing the gradient. If the first coordinate's the same, 2, 2, it means x equals 2 is the equation, which means it's vertical. And that is actually the equation then. The equation of a median, since it's a vertical line, is just x equals a number, x equals the first coordinate, 2, and we're done there. SQA Higher Maths 2021 Paper 1 Question 4. Determine whether the line passing through minus 4, 2 and 2 minus 7 is perpendicular to that other line. So there's a couple ways you can do this actually. What you could do is find the gradient of both and then times them together and check if you get minus 1. Or find the gradient of both and then check if the other one gives you a perpendicular gradient of the same as the one you did. I'll do it the first way because it seems to make more sense. So the gradient is, say, the first line is minus 7 minus 2 over 2 minus minus 4. That's minus 9 over 6, which is minus 3 over 2. So the other one, I've got 3y equals 2x add 9. So y is 2/3 x. 9 divided by 3 is 3. Which is the gradient of that one. I'll call that m1 to give it a distinction, is 2/3. Now I need to check what is m1 times m2. If it's minus 1, they're perpendicular. We know this. So minus 3 over 2 times 2/3. Well, that is minus 1. Therefore, since m1 times m2 equals minus 1, they are perpendicular. And we're done there. Okay, example 14, last one. SQA Higher Maths 2025 Paper 1 Question 2. Just as last year, if you're watching this now, find the equation of a perpendicular bisector of the line joining A and B. So, perpendicular bisector, remember, means if you've got a line, call it A and B, it's at right angles to that line, but cuts it in half as well. So I need my midpoint, I'll call that M. M is equal to 1 plus 9 divided by 2, 4 plus 10 divided by 2. That's 10 divided by 2 is 5. 14 divided by 2 is 7. 5, 7. Good. Now, I'll make that a capital M because it looks awful. Now, so let's move on to our gradient. The gradient of A and B are 10 minus 4 over 9 minus 1. That's 6 over 8, which is half in that, 3/4. But it's perpendicular. So the gradient of our perpendicular is minus 4/3 because m1, m2 equals minus 1. So now we can do y minus b equals m, x minus a, 3y minus 7 minus 4, x minus 5, 3y minus 21 minus 4x plus 20. I'll just move the y's and x's to the same side. 3y plus 4x equals 41. And that seems like a fine answer to me, but there's lots of other ways you can write that. And we're done there. Today we did a masterclass on higher maths straight line. Hopefully you found that useful. Remember to download your free guides below. And if you are interested in membership and you want that extra boost, we'll be doing this regularly for all the topics in higher maths. And I'll be giving you free homework PDFs to go along with that. And also we've got our last minute live streams the night before the exam, which are always very popular for that last minute boost. Take care, stay safe, and I'll see you soon.